The Japanese experiment module Kibo in the International Space Station ISS was completed a decade ago. This was also the year the technical demonstration of the first Japanese transporter succeeded. Kounotori has one of the world's largest resupplying capacities. It continues to carry supplies for various research, experiments, and observations to utilize outer space, and for advancing technology at corporations, universities, and international partnerships, as well as for the astronauts who are staying long aboard the ISS. Kounotori prides a success rate so far of 100%. Let's take a look at the mission undertaken by Kounotori. On September 24, 2019, Kounotori-8, heading for the ISS, was launched by the H-IIB rocket from the Tanegashima Space Center.
Systems are go. Engine start. Main engine ignition.
In about 4 days, it approached the ISS, stationed at an altitude of approximately 400 kilometers and orbiting the Earth at approximately 8 kilometers a second. The rendezvous capture system for this ISS berthing, or docking, was proven for the first time in the world through the development of Kounotori and has now become a global standard. The attitude sensor for the Kounotori originally controlled its attitude using the Earth as its axis. Kounotori-8 adopts the star tracker, determining its attitude with respect to the position of the stars. The attitude control was confirmed to be adequate at all times. And by employing a new type of resupply rack, the loading efficiency of supplies to be transported improved dramatically. Payload capacity has increased up to 30%. These two technologies were employed ahead of the new space station transfer vehicle, HTV-X, currently under development. And Kounotori-8 has been able to test effectiveness of both these technologies. On September 28th, the Kounotori-8, captured by the ISS robot arm, was berthed to the ISS. The 34-day resupply mission began. Transportation of daily supplies, water and food for the astronauts, as well as fresh vegetables and fruit, was one of the important tasks of HTV. New type batteries, indispensable for ISS operations, were transported by Kounotori-8, taking over the task from Kounotori-6 and 7. By transporting 6 battery units, the ship was able to confirm its high resupplying capacity. Kounotori-8 also transported experimental equipment for future space explorations, transfer ship development, and planetary explorations. One of these, the Communication Experiment Device for Small Satellite Optical Links, SOLIS, conducts bidirectional transmission via optical links, envisioning the same transmission as terrestrial networks. Experiments are conducted repeatedly for clear communication and transmission of video between Earth and outer space. The CBEF is used for biological and other experiments requiring artificial gravity. Biological samples are cultured or grown, and the effect of space environment is studied. Kounotori-8 has transported the CBEF-L, which, compared to the standard CBEF, doubles the turning radius of the artificial gravity generator. Increasing the stability of the artificial gravity generator gives way to more precise gravitational loading experiments. The Hourglass box, which has been transported along with the CBEF-L, is an experimental device with an hourglass containing simulated lunar sand. The simulated lunar sand in the hourglass is studied under low-gravity conditions created by the artificial gravity generator. This data can be applied to the development of vehicles necessary for landing on and exploring moons and planets. The Japanese experiment module Kibo also has the capability of deploying small satellites into orbit. Small satellites developed by countries, private companies, or universities that do not have their own means of space transportation are transported to the ISS. The data derived from these small satellites are contributing to global advancements in space-related technology and industries.
So now we're flying away.
Completing its 34-day mission at the ISS, Kounotori 8 detached from the ISS on November 2nd, 2019. On the following day, November 3rd, Kounotori 8 completed its re-entry into the Earth's atmosphere. Transporting essential supplies for ISS operation and various experimental devices, Kounotori 8 successfully accomplished its 8th mission.
はい、やはり月並みなんですけれども、無事に
This is not unusual, but it was the moment HTV arrived safely at the ISS and was captured by the
やっぱりここ
astronauts.
は非常に今まで
It was a moment we felt that everything we worked hard for was worth it, and I found myself going
や
yes.
はり嬉しい場面でした。コウノトリ8号機から新しい
From Kounotori 8, we newly installed the Star Tracker, replacing the Earth sensor.
それらは
The Star Tracker is a sensor that measures the direction Kounotori is facing in space.
いうものを測るセン
With
サ
the
ー
previous Earth sensor, Kounotori could only fly around the Earth or within visible range from the Earth.
コウノトリが飛行できなかったというところですけれども、
But now with the Star Tracker we have upgraded, so even if the Earth is not visible from it, Kounotori 8 can take flight if stars can be detected.
そのようなわけで、地球から、月に
Flight is now possible from the Earth to the Moon, or maybe in the future, further out into
飛行が
space.
可能になってます。
Kounotori 8 has tested and proven technology that leads to the future.
技術をしっかり
The significance of its mission has been very
意
high.
味が大きかったのかなと思ってます。
And now, in 2020, the space station transfer vehicle, Kounotori, is now heading for its final chapter. Kounotori will complete its mission with the HTV-9, scheduled to be launched in 2020, and will advance to the next stage.